what we have here is the 10.5 homework. I'm going to set up number 6 and number 9 to give you guys an example, hopefully help you get started. So the instructions say find the area of each regular polygon. So that's important. So regular polygon. Round your answers to the nearest tenth. So we're rounding. Number 6 says an octagon with side length 6 centimeters. Octagon is 8 sides. We're not given a picture, so I'm going to slide down and we can draw it. You don't even necessarily have to draw the whole thing. We have an octagon, so that'd be 8 sides. Maybe I'll just draw half of it, or we could continue it. Something more or less like that, 8 sides. But the important thing is it tells us each side is length 6 centimeters. So in our picture, we know a side. The other thing we're going to need to find is the apothem, because the area of a regular polygon is 1/2 the perimeter times the apothem. Well, we can find the perimeter because we know what one of the sides is. One side is 6 centimeters, and I have 8 sides, so the perimeter is 6, 8 times, 6 times 8. The apothem, if I put the center of my octagon in here, would be this segment, perpendicular to a side. There's my apothem. We can label it. The way we're going to find this apothem is by using a right triangle. So if I complete this right triangle, that'll help me find my apothem, because when we drew the apothem in a regular polygon, this would bisect this side, which is 6 centimeters, so it cuts it into 3 and 3, cuts it right in half. So I know one side of my right triangle, I want to find another. All I'm missing is an angle measure. We can find the measure of this angle. This process again, if you just imagine, I draw all my radii. I would have 8 congruent triangles because there's 8 sides. If I add up all of those angles, they make a full circle. So take 360 degrees, divide it evenly 8 times, and each angle measure in here would be 45 degrees. Now if any of these angle measures is 45, when we drew the apothem, we bisected that 45 degree angle. Right? If I had this line also drawn in, this whole angle is 45 degrees, the apothem bisected it, so in here we have 22.5, half of 45, right, 22.5. We cut that angle in half, so the angle in my right triangle is 22.5 degrees. Let me draw that bigger so we can see what we're working with. My right triangle, 22.5 degrees. I want to know this side, my apothem. I know this side is 3. This is not one of our special right triangles, so this is where trigonometry comes into play. If I'm looking from this angle, first label your sides. Opposite, adjacent, and hypotenuse. I know the opposite side. I want to know the adjacent side. So which ratio am I going to use? Think SOHCAHTOA. TOA is the one that I want. That's the tangent. My tangent ratio is the opposite side over the adjacent side. So the tangent of my angle, 22.5, is equal to the opposite side, 3, over the adjacent side, A. Now remember, if my variable is in the bottom of this fraction, what we do is multiply it over and then divide by the tangent of 22.5, so these guys make a flip-flop. They switch places. So move the A on over, and then move the tangent of 22.5 down into the bottom of the fraction. And there is my apothem. My apothem is 3 divided by the tangent of 22.5. We're going to put that into our equation just as it is. 3 over the tangent of 22.5. We don't want to round it too early. And what we'll want to do is this whole calculation. Take 3 divided by the tangent of 22.5, multiply it by 8, multiply it by 6, multiply by 1/2, and that would be the area of our regular octagon with a side length of 6 centimeters. Put centimeters squared on there. Alright, let's move on to number 9. Number 9 is the same instructions, but here we have a nonagon with radius 7 inches. So in this case, nonagon, that is 9 sides, nonagon. And in this case, we're given a radius, not a side length. So, no picture. We'll come down here. I'm going to draw just a part of it. I don't need the whole thing drawn. So, say this is part of my nonagon. We have 9 sides. What I'm given is a radius. So the radius goes from the center of my nonagon to a vertex. Say that vertex. It has a radius of 7. That's all I know. The area formula, again, is 1/2 the perimeter times the apothem. We don't know either of those yet. We're going to have to solve for both of them. And we're going to do it using a right triangle. So if I draw in an apothem in my nonagon, I've got a right triangle. I'm going to want to know this side, A, the apothem, and I'll want to know this side of my right triangle as well. We can call it X, because this apothem bisects a side of my nonagon. So if I can find the length of this segment, then the length of the side is just double that. So we're going to go after both of these sides. All I need to know is one of the angle measures in my right triangle. So to do that is the same process. Imagine if I were to draw in all of my radii in this shape. It's a nonagon, so what I would have is 9 congruent triangles in the center of my nonagon. And if I added up all their angles, it would make a full circle. So each one of those angles is 360 divided by 9 in this case, because it has 9 sides, 9 triangles, 9 angles in there. Each of those would be 40 degrees. Each angle in my nonagon, if I were to draw all the radii, would be 40 degrees. When we drew the apothem, we bisected that 40 degree angle, cut it right in half. So the angle measure in my right triangle is 20 degrees. 20 degrees. This is not one of our special right triangles, so we need to use trigonometry again. If I'm looking from my 20 degree angle, this is my opposite side, this is my adjacent side, and this is my hypotenuse. So let's start off finding my opposite side. How about that? I know the hypotenuse. I want to find the opposite side. Which trig ratio do I use? Which one involves the opposite and the hypotenuse? That would be my sine ratio. So the sine of my angle, 20 degrees, that's equal to the opposite side over the hypotenuse, x over 7. In this case, to solve for x, I just need to multiply each side by 7. These would cancel out. I would get x is 7 times the sine of 20. However, that is only partially helpful to me. I have the length of x. A side of my nonagon is double that. So if I want to know what a side length is, we're going to have to double that. But what I want in my formula is the whole perimeter, all 9 sides added up. So the perimeter of my nonagon is, I have 7 times the sine of 20, that's x, so one side would be double that, so multiply that by 2, and then I have 9 sides. this is the length of one side. I have 9 sides, so times 9. Or if we multiply 7 times 9 times 2, we would get 126 times the sine of 20. And we're going to leave sine of 20 like that because we don't want to round too early. That's my perimeter. We can go ahead and plug that into our formula. Area is 1/2. My perimeter is 126 times the sine of 20. My apothem now, return to our right triangle. The apothem is my adjacent side, and I know my hypotenuse. Which trig ratio uses the adjacent side and the hypotenuse? That would be my cosine ratio. So the cosine of my angle, 20 degrees, is equal to the adjacent side, A, my apothem, over the hypotenuse, 7. And the same step to solve for A, multiply each side by 7 so that these cancel out, and we just get that the apothem is 7 times the cosine of 20. That's my apothem. I'll leave it just like that to put into my area formula. 7 times the cosine of 20. And then to find the area of this regular nonagon with a radius of 7 inches, we just have to multiply all of these pieces. And then you round it to the nearest tenth. So hopefully that gives you an idea of the process in solving all of these problems at the beginning. They take some time. And that would be the process I would use to solve 23, 24, 25, and even 36 to a degree.